Hi. Oh, God. So we're just going to get started in a few seconds. I just want to start off and say welcome to Intro to Python. My name is Ying. My TA is Pri Oberoi. We're both from the Commerce Data Service. You can see our logo on the top left corner of the screen. Just a few things. I think for the books of the month in the library, the topic is Python. So there are a bunch of books. If you're in Commerce, you can check them out and see if you want to push and look deeper into Python. So just so the brief words, so the way I teach is feel free to interrupt me at any moment and just ask questions, and we'll see what will flow with that. So this is Intro to Python, and it's based mostly on Google's Python class. So this is the URL, and again, these slides will be available after class for everybody. But if you want to sort of check the material in a more web-based sense, most of the material is covered in this class, in this Google class. So Python is a very popular language for software development, and it is object-oriented and structured. So what that means is you're assigning values to objects, and it's structured in the way that you have if-while control loops so that you're used to. So if anybody who's coded before, this is probably how you're used to the paradigm of coding. And a lot of the design of Python is guided by something they call the Zen of Python. And that's something you don't really need to know in depth. Just know that like what makes good Python code is something that usually follows these tenets, which is like beautiful before ugly, explicit better than implicit, simple is better than complex, and so on and so on. So that's just something you should keep in the back of your head as you go on. So Python is the core language of Python is very useful, but there's a lot of things that you want to do that's not available in the core package. And when that happens, there are packages available that you can extend the usability of Python with. And so everybody should have followed, hopefully, the instructions sent out prior to the class. We're going to spend a few minutes just to make sure everybody is up to date. So you should have Python 2.7 installed and running in terminal. You should have Anaconda installed at the very least. So if anybody either on the WebEx or in person right now has any issues, we're just going to spend a few minutes, make sure you have all these things installed and they're up and running. Cool, I don't see any questions, so maybe this will be super fast. We'll just skip on forward. So why do we want Anaconda? So Anaconda is so if you're on Windows, you should run the command prompt. Is that what it's called? So if you press the window button and you type in run and you then press enter and then you press CMD, you should get a command line terminal, right? And in there, if you type in Python and if it launches, then you have installed it correctly. So that's just very basic. So I knew prior to class a couple of people were having trouble installing Anaconda. At the very basic level, if you have installed just Python 2.7 from the actual Python website, that should be able to get you through class at the very minimum. Yep. It's similar. It's similar. I think Conda has more support. Yeah, it's similar. There's also pip, which is available. But yeah, I think Conda is easiest it's like platform agnostic. It just works the same way across different OSs, so that's why we're sticking with Conda. Yeah, if you know how to install the packages in Python, just go through that. That should be fine. And if you cannot get it up and running, again, these slides and this recording will be available afterwards, so you can just follow along at some point if you can work on it afterwards. So, yep. So Anaconda is the full release, so it has a lot of the scientific packages that most people use for Python, but a lot of people are bandwidth constrained. So Miniconda is just the Conda architect for it, and none of the packages. So it's lighter, so you can install it, and then you can install the packages you want afterwards. So that's the difference. So in this class, I asked you to install 3 packages prior to this, and it's UJSON, NumPy, and SciPy. And SciPy just comes along for the ride because you need it for NumPy. But typically, we're going to cover why you would want to use UJSON and NumPy at the end of class. So if you have those installed, that would be beneficial. If you don't, you can just follow along with the slides. Okay, I don't see any more questions, so we're just going to go on ahead. So when you edit in Python, we typically, a Python program is just a text file. So it's just a series of lines of commands you pass to the interpreter. And typically when you save a Python program, we save it with the extension .py. It's just a way of differentiating. The interpreter will take any text file. It doesn't have to end in .py. Anything you pass along to it that has Python code in it, it will try to run. The thing you want to know is that you should not be using WordPad or Notepad. And the reason for that is because of the way Python treats whitespace. So on Windows, tabs are important in Python, and they are encoded differently for Windows. So you should typically try to use something like Sublime, Atom, or Notepad++, or even the default Python IDLE, which you can use to do the editing for you. So hopefully you have one of these installed prior to class, Sublime, Atom, or Notepad++. And that's the majority of what we're going to do our coding with and our exercises with. So I mentioned the Python interpreter. So the Python interpreter is just what you typically think of as the program, Python. So if you go into the command line, so if everybody has the command line open, and you type in Python, and the thing that runs after it, that is the interpreter. It runs in interactive mode, so you can pass commands to it. Right? Now, if you run Python space whatever program you saved, it'll pass that program to the interpreter to run the commands through it. So if everybody has Python open, this is just the basics. So everybody can try print hello world. And what that does is it prints out hello world. Pretty basic. So hopefully nobody should have any issues doing this first command in Python. Just be interactive. And so that's the most basic command for Python, which is print. Is how do you output things once you pass something to the interpreter, right? It'll spit out something to you. Now, how do you comment something out also in Python? How do you make it skip over a line? And that's the hashtag. So if you do pound, but not goodbye, it prints that hello world, but ignores the line that says, but not goodbye. Okay, so that's the very basic syntax of Python that we're getting started with.
A question we're getting is, do you need to have parentheses around hello world?
In 2.7, you don't. And in Python 3, if you ever decide to move to the newest version, requires parentheses, which is a change between the two.
And then there's no semicolon at the end of the line, so is each line an atomic command?
So each line is autonomous. So I'll get to it in a second, but whitespace matters in Python. So the indentation, the spaces after and before the line, and each enter of the line is important for Python. So that's how it derives a lot of the formatting for like if loops and while loops. So like I said, indentation matters. right? And so that's why you want to choose the correct editor, and that's because editors built for coding will pass tab as multiple spaces, whereas Notepad or WordPad will pass the ASCII equivalent of a tab, which is /t, which is different from multiple spaces. And the problem that happens is that when you pass that to the interpreter, it gets confused at what you're doing. So you want to have an editor that primarily focuses for coding. So when we talk about Python, there's something called a logical block. So a logical block is basically a series of commands that have the same indentation level. So if you tab over once for one thing, right, everything that follows that has the same tab level after that command is one block. And that is the logical block. So if the indentation is different between these, right, Python will throw a syntax error. It'll tell you something is wrong as it's trying to interpret the line. And that's why oftentimes the tab is so important, and how that tab is outputted into Python is so important, because if that is wrong, the whole interpretation of that is wrong. The way you program the logical block that it defines it on is wrong. So we're going to start with a very basic exercise for everybody, hopefully, is that everybody can start with creating a Python program, an external file that you save, that when passed to the Python interpreter will return hello world. So very basic, we've started with the command for hello world. Does everybody remember the command for that? It's print whatever you want, the string. So in quotation, print space, quotation marks, whatever you want to pass, right? So can everybody create a program, a Python program, that when passed to the Python interpreter will print out hello world? So we're going to take a few minutes and everybody can try this. And if anybody can runs into issues, they can just ask it, either in WebEx or in person. I'm sorry? No, just hello world. Just this string.
So some folks are getting syntax errors when they do print hello world. And one, print with a P should not be uppercase.
Yes,
Should all
it should be
lowercase.
So uppercase, lowercase is important for Python.
And how do they tell whether it's 2.7 or 3.5? How do they tell that they have 2.7? Because I think some folks might have
3.5.
3.5.
So to tell the version you have, if you just type Python into the command prompt, and when you load it up, it should spit out what version of Python it is, what it loads up. I'm sorry? Yes, yes. So yeah, like I said before, if you're in 3.5, you will need parentheses after print. You'll need to contain what you're passing to print in parentheses. So just give a little guideline for this. To create a Python program, you have to save an external text file in your editor, right, with the command print apostrophe hello world, close apostrophe, and then pass it to the Python interpreter. If it's in 3.5. So so this tutorial is in 2.7. So when you save it, right, you have to choose a location, and when you're in the command line, you have to go to the directory that file is saved in, right? So there's no specific place. Python is a program that can run from any directory. You have to be in the right directory for the program to be saved in, for Python to know what file you're talking about. So hopefully, most people should have that figured out, and it should work.
And for Windows folks, someone pointed out that if you save your your Python code to documents, and then you take the documents folder and drag it to your command prompt, it'll change it to that folder. So you'll already be in the right folder then.
Okay, that's good to know. Okay, so we're just going to move. Hopefully everybody, if they haven't been able to do it, at least has a good idea of what they're going to do to get this up and running. So here's something that we can build off of that, and that says why indentation matters. So this is a basic function and the call of the function in Python. So def is defining a function in Python. So anything that follows, we call, so in this function, we make a function called hello, and we're saying when that function hello gets called, print out hello world, and then print out the next line, hello again, right? And then at the last line on this, we call that function hello parentheses. And that's how Python knows this is a function, if you open and close parentheses. So you notice the indentation matters, right? Because everything in the function is indented one level over. So that's how Python differentiates commands that are in a function and commands that are not. So we're going to start with strings, which are the most basic, one of the most basic types in Python, and one of the things that you'll probably work with the most as you're working with Python. So strings are basically just any long concatenation. You probably worked with them in Excel, you probably worked with them in R if you've done that, or SAS, like any of the languages, right? It's just sort of the same thing. It's just a letter, a string of words, right, or letters. In Python, Python basically defines anything between either single quotes or double quotes as strings. Typically, you pass, most people use single quotes, but that's just a preference. Either one works. And you can pass different levels. So if you have a string that you're enclosing in single quotes, you can put in double quotes inside it, and it will show up in the string. So the reverse is true. So if you want single quotes in the string, you can enclose it in double quotes. So you'll see in the last line, it will spit out double quotes, hello, world, close double quotes. So that's basically anything that's in quotations is a string for Python. And the thing about strings are they are basically immutable in Python. So Python freezes it. You cannot change a string once you have defined it. So the way we manipulate strings is basically we make new ones as we output it out. We don't change the existing string that way we have. So you'll see here, say I define some variable as hello and some variable as world, and I want to print both together, right? We combine them. We don't edit one string to add world. We combine the two together. So basically here you'll see the plus basically is the concatenation for strings. So print hello plus world gets you hello world with no spaces. So how, now that we know we can construct strings, how do we access certain slices of that string? Right? So how do we get a character, like the 5th character or the 6th character in a string, if we want to slice it up and edit it that way, right? Pull out certain parts of the string for new things. And so the way to do that is the square brackets. So that's very standard syntax in Python, and you'll notice it over and over again if you want to access a certain part of something. So if you want, say, in the first command here, print hello world square brackets 1, you'll see the return on that. If you put it into Python, you'll find it'll return a lowercase e. which is the second character in that string. And basically, that's because Python starts counting from 0. So 0, 1, 2, 3, 4, 5, 6, and so on.
Can folks, if they're using command prompt or terminal, the code they're seeing on the slides, can they just type that in to see this work?
They should open Python, just call Python alone in the command prompt, and then in Python type in these commands. So that's something you can do as you follow along.
So in command line or in the terminal, you see the you'll see that it'll change.
Yes, you'll see it change from the command line, which will probably give you the directory, to just like the greater than sign or something, and that'll show you you're in Python. And then you can start typing in these commands as you go along. So that's useful, how to slice strings to get certain parts of it out for you to use, right? But what if we want to just know how long a string is, right? And that's also very easy to remember. So the len command, right, the len function basically gives you back how many characters are in that string. So in the second line, print len hello world, how many characters do you think it spits back out? 11, why? Why not 10? Yes, absolutely. So that's something you should keep in mind, that it counts every single part of that string, including the space. So in print len hello world, it counts hello, which is 5, the space, which is 1, and then world, which is 5 again. So that's useful in upper bounding when you're trying to slice different parts of your string, right? So if you're trying to figure out, I want the last character, but what is the last character in that string? For a very long string, you can just do len in Python and you can see what it is. And so what if you try to get a character that doesn't exist in the string? What if I want the 12th character in hello world, right? When I put in the index into the square brackets, that doesn't exist. Well, Python will throw out an error. It checks it before it runs it. So you never have to worry about it throwing out an empty space by default or anything. It will stop the program if it finds an error. So this is just something anybody can test out. So because Python is object-oriented, we can define s, right, short for string, as high. So if we were to print s1, right, we would get back I, the second character in that string, because we start the count at 0. If we were to print in len of s, the length of s, we would get 2. Now, what if we wanted to add to that string? We wanted something longer to print out. We could add space there, s plus quotation mark space there, we would get high there. So like we saw before, concatenation is just a plus sign. Very simple, right? Much easier than Excel or, I think SAS, like concatenate is a huge function, too much letters, right? You just take the strings you want and you concatenate them, just add them together. So here, the issue of that is, though, in Python, you have to be aware of how Python defines different types of variables. So if we define pi as 3.14, that is defined as a floating point variable. So it is a numeric variable. And if we try to add that concatenated to a string, Python will throw an error. Because it doesn't know what you're saying. Because if it's a floating point variable for one end, and it's a string for the other, it doesn't know to concatenate or to add them together. Question? Mm-hmm. Yeah, so a lot of that is when you initially define something, if it's an integer, it'll try to decide what type it is. But a lot of that is in the background. But you can explicitly define it as something else if you want. Okay, sorry. So the question was, an attendee asked if in C and in C++, you have to explicitly define the type of variable you're assigning it to. Like, is it floating point? Is it a string? In Python, it manages that in the background a lot. You can explicitly define something again as something if it assigns it wrong, but a lot of that is managed in the background. So the problem we have here is that we have a floating point number and we have a string, so we want to concatenate it because we want to get the value of pi. So how do we do that? So the way to do that is to convert it, right? So we have a wrong type. Python has defined it as a different type than we want. So to convert anything to a string, the function is string quotation marks. So if pi is 3.14, and we want to concatenate it to a string, we do that string plus convert our variable into a string, right? And so you see on the third line, that's how it works. If you try the second, it will throw back an error for you. So now we're going to go into string methods. And so
could you also just place the float inside quotes to make it a string?
oh yeah, if you define the initial pi variable, if we go back one, let me see. So if we define pi as quotes 3.14, then it would be defined as a string, right? So Python by default tries to guess what type it should be, right? And it's thinking if you define 3.14, that's typically a number. You probably want to do some math on it. So we're going to go into string methods, which are methods are basically functions on top of a specific object in Python, right? So it runs on the object that's defined. Hold on a second. Is there a reason why this is popping up? Okay. So if we were to say, define a variable s as a string, right? We've assigned it some value that's a string, right? And we want to make it all lowercase, right? We want to convert all of the characters in the string to lowercase, right? We use a method, not a function, right? So we do s dot the method. So in this case, to make things lowercase, we do s dot lower parentheses. And so running the method on the object converts it. It's basically a function on that specific object. So the first method we're going to go over is s.lower and s.upper. And so that's very basic things is you can probably guess, convert a string into lowercase or uppercase. The next one is strip. And that's probably very useful for a lot of people, which is if you have a lot of leading and ending blank spaces in a string that you've defined, say from a file or a CSV. If you do .strip on it, you will strip off the leading and ending blank spaces. So the next set of them, and there's a whole series of them you can look up, is basically a test on what is contained in the string. So if you do is alpha, it tests if there's an alphanumeric character in the string. Is digit if there's a digit. Is space if there is a space in the string. These are basically tests to run on the string. If you're, say, trying to make sure that like the zip code is entered correctly, you can test, is there a digit in there?
The method lower already imported via the default library.
So the question is the method lower already imported in the default library? So yes. So methods are attached to objects. So these methods are attached to strings. So the minute you define a string, these methods all work for that string. So that's why I say if we define s, say s equals some string, like hello, quotation marks hello, right? All these methods work automatically with that string. So the next set are starts with and ends with. So you could probably guess what they mean. You're just trying to test if the string that you defined starts with this other string that you've put in. So you're testing basically s that starts with other, you're testing if s, that string, starts with other. Pretty self-explanatory. And same with ends with. So this is another one which is probably useful for a lot of people if you're trying to find a very specific substring inside there. So if you have a very long string and you say you're looking for, I don't know, like street or road, or if you have an address field and you're looking for a very specific thing in there, you can search for it by saying s.find, and it will look for, in the bigger string, the string you pass along the smaller one. So it will look for other in s. It's important to note for people who are familiar with regular expressions, this command does not take regular expressions. It takes just a flat string. And so what you will get back from this method is the index of the first character that substring is found on, or -1 if it does not find it.
How does someone look up functions like this? Like if you kind of know what you want the function to do, how do you look it up?
All right, so the question is, how do you look up functions if you know kind of what you want to do, but you don't know the actual explicit command for it? And so that's a great question, and the answer is that, thankfully, Python is super popular. And the internet, a lot of people use Python, so you can type in, basically in Google or any search engine, a lot of things that will show you those commands. Like if you ask, like, how do I convert a string into a lowercase in Python? I bet you somebody has asked that already on the internet, and they'll have the command there. So like Stack Overflow, Python 2.7 handbook is there, just the documentation for it is there, is very useful. I find myself going back to it a lot of times. So what is useful for sfind is to say if you want to slice, if you want to look for the slice of some specific string in your bigger string, right, and you want to know where that starts, this tells you, right? So if you want to know where other starts in S, right, it'll give you that index, or if it doesn't find it, give you -1. Next method is replace. So you want to say, in a string, you want to replace RD with road, right? So you would do that. Or if you want to, in this case, want to replace old with new in S, you would do that, right? S that replace the old thing with the new thing. And it replaces all the incurrences, so not the first one. Everything, anytime it finds old, it will replace it with new. Okay. So this is also, I think, a very useful one for a lot of people. You have a very long string that has not been broken up, and say you want to break it up. Say you have the full mailing address of some place, and you want to break it up into, say, its component parts. You want the state, the street name, maybe the zip code, right? So the way you would do that is to use split, the method split, right? And so you have a string, you call split, and you pass it to the eliminator. Basically, what character do you want to split the string on, right? So if, I don't know, if the zip code is separated from the state by a comma, and you know that it's true for every single mailing address, you do s.split, quotation marks, comma, right? And it will split the string on the comma. And again, it does not take regular expression for people who know what regular expression is, just as a warning.
Are all string methods case sensitive?
Yes. So are all string methods case sensitive? And they are. So everything you do in Python should be case sensitive. So here I show you basically, you can pass anything, right? You don't have to define it beforehand. So here I'm just saying this string, AAA, comma, BBB, comma, CCC, I want to split it on the commas. And what it will return to you is a list. And we'll get to that later, but just basically a list of those things split apart. So AAA, BBB, CCC. So one of the easy things as a shorthand that you should know is that if you don't pass a delimiter to split, it'll split it on white spaces. So any string you pass, if you don't give it a specific delimiter, it'll try to split it. Python will try to split that string on white spaces. So what is the opposite of split, right? Which is, what if we have a bunch of component parts that we want to join together, right? Say we have a list again of things that we just broke apart, AAA, BBB, CCC. And we want to join them together, but this time we want to join them and add hyphen, hyphen, hyphen in between each join, right? How do we do that for a series of strings? So that would be join a list, right? So we have S would be the thing you want to join them together with, which is the hyphen. So on the bottom you'll see, if I want to join AAA, BBB, CCC, but in between each of those elements, I want hyphen, 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 I would pass hyphen, 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 join the list. And you will get basically AAA, hyphen, 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 BBB, hyphen, 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 CCC. So this is useful in the fact that, like, if you have a long string of, I don't know, basically like characters broken up, and you want to join them back together again. So you have component parts of, say, a mailing address. Somebody's filled out the street name, somebody's filled out the zip code, but they're on different fields, and you want to pass them and join them back together. This is how you would do it. And so we mentioned before how to do string slices, right? And so here's a very simple way of thinking about it. So if we have a string that's hello, right? Python starts counting from 0 as you try to slice that string. So if you're to call the first character, you want to do the index 0. Right? Second one, 1, 2, 3, 4, right? So on and so on. But Python also takes negative values. You can go backwards. Right? So say you want, because there's a lot of times you have a very long string and you don't know the length of it, but you know you want the last 6 characters, right? Say you know the zip code's always at the end. You want the last 5 characters of that string, so you can do backwards also. Take the negative number, right? And here, Python starts counting negative from -1, from the last character onwards. So H would be -5. So this is just a useful way of visualizing how Python counts different characters. So let's stop here, and everybody can try and exercise. And so is there, can people try to slice star is here to get here is star? So we're just going to take a few minutes to try to do this in Python, and then we'll work it out in class together. I can answer questions while people are working.
Is there a method that allows you to search a string using regular expressions to look for patterns in a string like zip code?
Right. So that is not in this course, but you can look it up, and there is a regular expression package for Python that comes with the installation of Python. So it is RE. So if you just search RE space Python in Google or something, it will show you the documentation for it, and that will take regular expression searches.
Can you go back to the slide that shows the syntax for how to slice a string?
Yeah. So probably something that would help, and I just noticed that I forgot to put it in here, is that if you wanted to slice a series of numbers, you wanted a sequence of characters, right? Say you want the first 4 characters or something, you would do in square brackets the first character colon the last character you want. So if in here, for this example of s=hi, if I did 0:1, it would give me the whole string. It would start with the first character, it would end with the first character. So let me go back to the exercise and give everybody about 3 minutes left, and we'll go over it together. And again, if you have any questions, send it in WebEx, raise your hand, and come around and help you. But we'll go over the solution shortly. Yeah, so what is the syntax to get a subsequence? It is the first character colon the last character, number. Yep. So hopefully everybody has gotten a chance at least to try it. If you're stuck, we'll go over the solution together right now. So let me escape out of this and open up Python. So for people who have Mac OS, this should look familiar. I'll make the view bigger. So let's do Python, right? So we've opened the interpreter, and it should get us this, right? So let's define our string as star is here, right? And so if we were to print s, that'll get us this, right? Hopefully everybody got this far, right? So how do we get here is star? Anybody have a clue? So we want the last 4 characters to be the first 4, right? So we do s negative 4 to negative 1, right? So that's the 4th character to the last character, right? plus space plus the middle two. Does anybody know what are the positions of the is? Five and six? Yep, okay, so we can do 5 and 7. 5 and 7, right? And then we add star, right, which is 0 to 4, right? So I think hopefully that gets us here is star. Watch this not work out. Oh, we missed it. Right, so we're off by 1 here. -1. Okay, let's just do it regularly. 8. So we can keep fixing this to make sure it's right. There we go. Questions? Okay. Let's go back. I'm sorry. Okay. So, and this is something often I find myself confused about, is that like the end character is one before the one you specify. So if 5 to 7 gets you only 5 and 6, and we wanted the space afterwards too, so 5 to 8 gets you 5, 6, and 7. Okay? Oh. Okay, so -4 to -1, it ends before the last character. So if you do -4 to -1, you get HER, and it stops before the E, because it stops right before the index that you ended on. So it goes up to, but not including. I'm sorry, say that louder. Yeah, so if you do -4 to 0, it just gets you the blank space, because it doesn't like messing back and forth from negative to positive. So if you just input it without the colon, you get the character that you're specifying. But if you do a colon, it stops before the last character you're specifying. Right, yeah. So I think so. Could be wrong. And again, this is something you can just look up by yourself.
And so a question is, why don't we use split and join methods for this problem?
Yeah, you can do that too. So if you do -4 colon and you get and it goes to the end. So why don't we use split and join for this? Again, you can do that. This is just an exercise to see if you can slice it. So there's many methods of way to rearrange and remix the string you're given. This is just one way of doing it. Hopefully that shows up. Okay, perfect. So now that we can reasonably remix and rearrange strings, how do we insert values of other variables into a string? Say we want something conditionally, right? We want to put in the value of, we want to print out the value of the zip code, right? Depending on what the zip code is every single time, right? So we have a string, and the way we can input something into the string is something, if people are familiar with printf, and it works that way, it's basically the percentage operator. So if we want to input a variable that is a integer, we do %d. If we want to input another variable that is a string, we put %s into the string. If we want to put a floating point, we do %f or %g. So you see on the first line of the example, we want to put in 3 is 3, right? So the first thing we want to put in is the integer is 3, so we put into the string %d. The second thing we want to put in is a string, is the actual word 3, so we do %s, right? So after the string, we do percentage and then parentheses what we're trying to put into it. And so in Python, that anything contained in the parentheses, a series of things, we call that a tuple. And so it's basically anything contained in parentheses separated by commas. So if we pass this first line in Python and we print text, it'll get us 3 is 3. But what if we have a string that's overly long? We have a bunch of things we want to put into it to build out our sentence, right? So on the second line, you'll see we can actually contain that whole thing in parentheses, and then Python will be able to differentiate if it spans multiple lines or what you're trying to replace with. So either one works.
Is there any difference between using double quotes or single, like apostrophe there?
No. So like I said, strings don't differentiate between them. So you can use single or double quotation marks. It's really just a matter of preference. Okay. So regular Python strings that we pass in quotation marks, they are not encoded as Unicode. And so for people who are familiar, Unicode is a more extensible range of characters. And so sometimes you may want to pass Unicode characters in. Right? And the encoding for that is very easy. If you want to Python to encode the string as Unicode and not just regular bytes, regular strings, you just add a U to the beginning of the quotation marks. And so here you'll see \U081E is actually a Unicode character. And so if we've specified to Python that we want to encode this as Unicode, it will actually pass that into Unicode as a character, whatever it's associated with. And you'll see \XF1 is also a Unicode character.
What is Unicode and why does it matter?
So Unicode is, I think, let me think of a way to describe it. It's probably, you'll probably encounter it the most if you're looking at non-English characters or anything. It's a way of extending the traditional ASCII to more characters, to extend the alphabet. So if you're dealing with a lot of, I don't know, I know like katakana or characters or something, a lot of that's encoded in Unicode because it has more character space within it, so you can put in more characters into it. And so that's just a thing. If you deal with Unicode a lot, that's something you may have to do a lot. Awesome. So it may look like a small difference if we're just putting a U in front of it, but a Unicode character is actually very different in Python from a regular string. But the good news is that a lot of the libraries and most of the things you'll deal with, they account for that. So you never have to worry about the difference. So a lot of the functions, a lot of things that work for regular strings, most of them will work for Unicode. There are probably a few exceptions, and when I don't know any off the top of my head. Most of the stuff I've ever done, it just works. But if we want to convert that string back into bytes, specific bytes. The way to do that is to call a very specific encoding of it. So if we encode, so encode is a specific method on a Unicode string, so it's unique to a Unicode string. And if you pass a specific method of converting that back to bytes, it will convert it back to bytes. So UTF-8 here is what we're converting it to. So we have a string that we had before. We do dot encode the conversion, right, which is UTF minus 8. That conversion converts basically into, I think, like 8 bytes strings, like characters that are 8 bytes. So that conversion is if you want to convert back into bytes. Now, say you had that byte and you regret that choice, and you want to go back to Unicode. Well, there's a function for that too, and it's just Unicode, the string you converted, and the conversion that it is currently in. How do you convert back? So you would put in UTF-8 also. So there's ways to go back and forth for that. For the most part, if you don't deal with very special characters, or if you don't deal with data sets that have those, you probably will never encounter this. So moving on from strings, say we want to begin programming some logic into our program. Like I said before, Python is very, it treats whitespace very specifically because it looks at the formatting of how you write your program to decide what belongs where. So it doesn't, unlike Sass or unlike R or like a lot of languages, it doesn't enclose things in curly brackets or square brackets or parentheses. It looks at the way you format it. The indentation that tells it what belongs where. So if the traditional if statement is the same pretty much everywhere you see it. It is if. And so it is, the syntax for it is if a logical test, colon. And then that is the initial statement, and anything in that test that should run is indented one level over. So you'll see an example later. But you can extend the if statement to else if, which is ELIF, or else clauses, right? You can add that onto it. So those are the ways you could do it. Just like a word of advice is that generally, Python treats logical tests, logical values as 0, 1s. So if something's false, it can be a none, a 0, an empty string, an empty list, an empty dictionary, all these things that are zeros, they just treat as false. So if you're testing for false, you can test for that. Likewise, if it's true, it's 1. So traditional logical operators are all there. If you're familiar with any coding, it's double equal sign if you want something equal. If it's not equal, it's exclamation point equal sign. And then the traditional greater than equal, less than equal. And the Boolean operators are and, or not. So we don't use, Python does not take the 2 pipes, does not take the 2 ands, the ampersands. You have to spell out and, or not, lowercase.
What is the length of indentation? Is it 1 tab or 2 tabs?
It is 1 tab. It can be defined either way. Python just, it takes it as white space. So if your editor defines that as 2 spaces or 4 spaces, it can be either or. That's why you should use something that's not Notepad or WordPad. So here we have an example of a if statement. So say you have a variable that is the value of the speed something is going at. And we want to see if it's going over 80 miles per hour, right? So if it is, so here in the statement you'll see if speed is greater than or equal to 80, colon, right, do all the commands that follow. if it's indented one level over. So here, if it's over 80, print license and registration, please. Now, test if my mood is terrible, and if the speed is really fast, if it's over 100. If it is, you have the right to remain silent. Right? If my mood is only bad and you're only going slightly faster at 90, I'm going to have to write you a ticket. And then write a ticket, calls the function write ticket. Else, let's just try to keep it under 80. So you'll see the indentation levels, right? So the first logical block in if speed, everything that's indented 1 over is in that block. It follows those commands. The second, if mood equals terrible, you indent 1 level over again, and that's how it knows that this command, the print, you have the right to remain silent, is executed if that if statement is fulfilled. So Python treats those indentations as the way it determines logical blocks.
What is the difference between else and else if or else if?
So that's a good question. So what is the difference between else and else if? So else if is if the first statement, if the preceding if statement is false, and I have an additional statement I want to test, I do else if. Right? Else if this statement is true. Else, just else alone, is if I just want everything that is not that does not fulfill the preceding statement. So everything that doesn't fall into terrible and greater than 100 or bad and speed greater than 90, just print this out.
So if there's no end if statement, how do I end the first if statement?
So that is, again, by Python. So if you indent back a level, right? So how Python knows you're done with the if statement is if the next line is indented to a previous upper level. So you'll see else if is indented back to the same level else if is, so it knows that if statement is done. That all the functions that are going to run on that if statement are done.
Does this make it more difficult for tracking your code versus using curly brackets?
Okay, so does this make it more difficult than tracking in the traditional way? So you'll notice in the design of Python, it tends to say simple is better than complex, like beautiful is better than ugly, it's all those things. So this is a way for Python to enforce formatting on you. So if you're in the curly brackets, you'll oftentimes, I don't know if you've experienced it, is that you'll find code that's sort of like it's one continuous line that has like multiple if statements because it can contain, as long as it's into brackets, the indentation doesn't matter. It makes it very hard to parse, right? So Python forces you to code with the formatting. So that way, when you read it, if you're familiar with the parsing, you can see right away, well, this is indented this level, so this precedes this, this follows this, right? So this makes it easier for you to parse as you read code.
Why isn't that last else statement? Why isn't that last else statement in line with the if?
The print statement?
The else. Why isn't it in line?
Right. So the else statement is in line with the second if statement, right? So it's attached to that if statement, not to that first one. So it's not else things that are less than 80. It's else things that are not terrible and not greater than 100 and not bad and not greater than 90. Right. So the indentation tells you which if statement it's attached to.
So what is the syntax to break a single command into multiple lines for readability? And I think also might be helpful to talk about what a command is in there.
Say that again, I'm sorry?
What is the syntax to break a single command into multiple lines so that it's easier to read?
Okay.
And have you done that here?
No, so like a single if statement is not broken up. So typically, Python treats a new line as a new command that you're passing to Python, right? The indentation tells you which logical block it belongs to. And so you typically don't do multiple lines if you're passing multiple statements. That being said, if things are contained in parentheses, often Python will span multiple lines to finish the command. So if I were to contain this logical statement in parentheses and it span multiple lines, it should probably work. So as you get familiar with Python syntax and the way you code in Python, this will become very easy to parse and much easier than most other languages. So here's a much easier one. And I can make it all in one line. So if speed is greater than 80, just print this. And I don't need to put that on the second line, I can put that on the first one. So Python checks for the colon after an if statement. It doesn't need a new line for the if statement. And you can do that, so you can combine those into one line if they're short enough, as a compact way of coding. Okay, any questions? We're going to go on. So we talked about strings and if statements, and logical Boolean operators. So the logical next step is really to talk about what are the mathematical operators. Like, we're not just going to work with strings, obviously, or we're not just going to work, in if statements. We're going to want to do some math at some point. And so the traditional operators work the way you think they are. So plus, minus, divide, multiply, which is just a star. They all work the way you think they are. Two numbers, you add them, they add up. If you want to do an exponent of something, you do double star, right? If you want to do the mod of something, you do percentage. So like 3 mod 2 is 1, right? So if you're trying to get modulus of some number, you can do that. In Python, there are no plus plus, or for people who are familiar with like C or C++, there's no plus plus operator. So there's no function that automatically iterates and adds 1 over. What will work though is plus equal. So if you want to do C, like A plus equal 1, it'll do that over. So the syntax is plus equal minus equal. Now, the other special case is if you just want integer division. So you want to divide something, but you don't want a floating point. You just want an integer of it. It's 2 double slashes, 2 forward slashes. So 6 integer division by 5 is just 1. It doesn't give you the remainder. So that being said, we're probably going to move on to the type in Python that you'll probably work with the most, which is probably the most useful thing, is something called a list in Python. And it's exactly like you imagine it. It's just a list of things. And the way Python denotes a list is anything separated by commas contained in square brackets. So they work very similar to strings. You can use len on it to get the length of the list, how many items are in the list. You can use square brackets again after the list to get a certain item in the list. So you want the 6th one, or you want the 6th to the 7th, so on and so on. And again, it starts counting that index again by 0. So all these things are consistent between strings and lists. So let's see how a list is built. So let's say we want colors, and we define that list as red, blue, and green, RGB. The way to define that would just be square brackets, red, blue, and green, separated by commas. Now, if I wanted the first element of that list, it would just be colors, square brackets again, 0, right, the first element. If I wanted the last element, it would be colors 2. If I wanted the length of it, it would be len of colors. So all very self-explanatory, and they work pretty much the way you think a string works. So the thing to be aware of is that unlike like Fortran or C++, or a lot of those languages, Python does a lot of the memory management on the background for you. And so it tries to save memory when for you, and it tries to clean it so you don't overwhelm your computer. And one of the ways it does that, and one of the quirks that you should be aware of, is that when you make a new variable equal to an old one, it doesn't make a copy of it. It just assigns it to the same part of the memory. So if I had defined colors before as red, blue, and green, and now I say B is equal to colors again, I didn't make a new copy of that list. I just assigned B to the same list that colors is assigned to. Now, the part that you should be aware of is because they're pointing to the same part of memory, if you make a change to colors, say I added something to colors, right? So I added a new color, then if I call B, it will have that new color because it's calling the same place in the memory. So an empty list is just square brackets. So if I wanted to define an empty list, it would just be square brackets. And the way why that is useful is because a lot of the times you're building a list up. So you have you're iterating through, say, a file, or you're iterating through a number of rows, and you want to pull a specific value from that, and you're adding it to a list, right? You want to pull that list. You want to build that list as you go along, as you're looping through it. So that's why you oftentimes you define an empty list before you start it, and you start adding to it afterwards. So that's how you define an empty list. So how do you append two lists together? So you just have one, and you just want to add the other one to the end of it, the same way you do with strings. So how do you concatenate them? It's just the plus sign. So if you have a list, and you have another list, you just do plus, and then it just gives you the concatenation of the two. So 1, 2, plus 3, 4 equals 1, 2, 3, 4. So in many ways, it works just like a string. If you think of a string as a list of characters.
So does it matter whether list elements are enclosed in square brackets or regular parentheses?
List elements have to be enclosed in square brackets. That is the way Python determines something is a list. In the same way Python determines something is a string if it's a quotation mark, something is in a list if it's in square brackets. Parentheses will not work. And so now that we have a list of things, oftentimes what you want to do if you have a list is either to build it up, you're going to loop through something to add things to it, or you're going to loop through something to do something on the list. And so that's a for loop. And I'm sure anybody who's had any code experience knows this. For Python, the syntax for loops is very simple. It's for the variable in the list. Right, so you'll see here, for var in list. So I have a list of things, and I can call each element of it something, I'll call it var. So for var in list, we'll loop through every single element in the list and call it var for each of that. The thing you should be aware of is that as you're looking through a list, do not try to add things to that list or remove things from that list. It'll mess it up. You should generally try to make a new list and add things to that, or you should try to do operations on that list. Do not try to add elements or remove it. So here we have an example. Say squares are 1, 4, 9, and 16. And we start the sum at 0. And say we want to loop through it, and we want to add all these numbers up together. So for numbers in squares, colon, and the next line, indentation, we want the sum to be plus the value of sum again, the value of the number again, right? So we keep adding the number onto sum every single time we iterate through squares. And if you were to print the final sum, you would get 30. It's a good way. I'll give everybody a few minutes to try to test this out. And again, if you have any questions, send it through WebEx or raise your hand.
We're getting asked, for num in, is that the keyword to initiate the sum process?
No. So for num in squares, that line is to call the for loop. It's saying for every element in squares, let's loop through it, call that element each time num. Now the next line saying sum plus equals num, that is where we're saying for each time we loop through it, add num to sum.
Would it work exactly the same if num were replaced with x or a or just anything else?
Anything. You can call it anything you want. So for num, that's the part where you define what you call the variable for each iteration. Yes. Yes, you have to put the tab in, even if you're in the just the interpreter by itself. Again, because Python interprets whitespace as logical blocks. So if you don't, it thinks it's a new line again, and you get an error. Do you have a question? So that leads me to a good point, which everybody should be aware of, is that you can call num anything you want. You can call it x, you can call it y, but there are some things you want to avoid, which are things that Python already defines as something. So like a list is something defined. So don't call that a list, because it will overwrite what Python default uses list as, which is a list, which is very useful. You don't want to overwrite that. You don't want to call it a len. You don't want to call it anything that already is defined for Python. And in general, those things are rare, and the syntax for those are very unique, so you probably won't overwrite those. So like typically try to avoid things that you already know, like lists, like string str, like all those things and so on. Question? It's a tab. You should press tab in the IDLE. If you're in the just the Python interpreter, it will convert it to spaces. So it's technically a tab, but in the Python interpreter, that converts it to spaces. So yeah.
Why is the editor highlighting sum?
Why is the editor highlighting sum?
Why is it showing up, let's say, like in a bold red or something? Is it a method or is it a?
Yeah, and so like I said before, so that's one of the things you should be aware. So sum, obviously, you'll imagine is a function in Python. So here, because your editor, like the editor imagines that that's a function already, so it highlights it. So that's why.
Was num defined somewhere else, or does it represent number?
No, num was not defined anywhere else. Num, I use num because it's shorthand for number, but it doesn't represent anything. So it is what I call each iteration as I loop through the list squares. So each time as I loop through, so the first time I loop through, num is 1. So second time, num is 4. Third time, num is 9. Fourth time, num is 16. That's just what I call that element as I loop through it. So it's defined the moment I write the for loop statement.
Do you have a question back there?
I'm sorry, can you say that louder again? So yes, you can put it in the command line. You need to tab over for the next line over, or it will get you an error. Since people are having trouble, let's try this together. So squares equals, what was it, 1, 4, 9, and 16, right? So if we do squares, it'll give us that again. Great. So let's do sum equals 0. So sum is 0. So if we loop for num in squares, you'll get the ... right? Hopefully that's Python telling you that it thinks you're in the logical loop because you just put in the statement. So now we need to tab over and say sum plus equals num, right? And you'll get a ... again. It's saying, do you want to continue with another command? Well, we don't. So that's the function. So it's run it, because the minute you're done with the logical loop, right, because it's saying you're not indenting anymore, you're not doing anything else anymore, you're done with the logical block. Now if we look at sum, you get 30.
If you want to comment out a whole bunch of lines, a block of code, how do you do that in Python? Is there a syntax for doing that?
We mentioned that earlier. So commenting in Python is really simple. You start the line with a pound sign. So this doesn't matter because it doesn't, right? Nothing happened. But if I were to type this doesn't matter, you get an error.
But there's no way to comment out a whole bunch of lines at the same time.
Okay. So you're saying that is there a way to block comment something? No. So you just start each line with the pound sign. There is no block comment.
And usually your editor will have a way for you to do that in bulk, so you don't have to do it manually.
So one of the plus sides of using an editor that's designed for coding is that it has shortcuts that'll say if you highlight these lines, just comment all of them out. And that's a plus sign. That's a plus for those editors. Python itself does not have a block comment command. Okay. So hopefully everybody at least gets this point. So you saw before, there's the in that we did, right? So for num in squares, it's saying for every element in squares, call it num. Now, if we put in into a statement that's an if statement, that's a logical test. So if we were just to do a statement with n alone, it tests if something is true or false. So say we have a list, Larry, Curly, and Mo, and we want to test if Curly is in the list. We say curly in list. And that works just by its own. And it'll return a true or false statement in Python. So we can test that out here. Right, so just check if we define list correctly. Now, let's see if curly is in the list. So in works without that if statement. You can put it in the if statement because it returns a true or false, right? So anything that returns a true or false is 0 or 1, it can be passed to the if statement as a test of true or false. So if curly in list, we tab over, let's say print yes, right? And it prints yes, because the test gave back true. So this is a good way of testing if a specific value is in a list, if the list is super long and examining it manually is not reasonable. So we saw four number in squares, and that works on a list. But that same thing will work for a string if we want to iterate over every single character in a string. So say we have something, some string, and we want to print each character one by one. So we can iterate across that too, because in many ways, a list and a string are sort of identical. Python has the same methods for both. So for character, for ch in s, print ch. It'll print each character one by one for the string you've defined. So test this out for everybody. So let's define a string as hello, or let's add a space. Hello world for character in s, print character. And what it should do is print it out each character line by line, like a new line for each character. And you'll see it prints it out line by line. And so you can loop through a string the same way you can loop through a list if you want to do certain tests on each character of a string. So how might this be useful if you're trying to say, I don't know, round a certain, say you have like a grocery store receipt or something, and you're trying to round the values of it. It's all in a string. You want to pull out certain parts of it and add it up or round it. You can convert it into an integer and round and then add it up. So that's how this is useful if you want to loop through a string. Yes. Right. So like ch and num, they're defined only within that logical block. Right. So you can use ch somewhere else that's not in that logical block because it's only defined as it's iterating through that loop. The minute that loop is done, it's not defined anymore. No, no. So Python in the background will clean it for you. Right. So it's only defined slowly through that loop.
If you wanted to pick each word or print each word, would you have to convert the string into a list of strings?
So if you wanted to print each word and not each character, easy way to do that would probably be the list method split. If you wanted to split it, we can split it into a list and then print each element of that list instead. Right, so we can test that. Let's see if that. So S is still hello world, right? And if we do, let's do A equals S dot split. So if we don't put in a delimiter for split, it splits on a white space, right? And when there's only one space, white space in S, which is the space between hello and world. So if we do that and we look at A, we get hello and world. So if we wanted to print or for word in A, print word. And you would do it that way. Okay. So moving on, What if we want a sequence of numbers in our list? We want to auto-generate a list of numbers. We just know we want something from this number to this number. So you want from 2010 to 2015, right? That's where range comes into use. So range basically generates a list from 0 to n minus 1 of whatever n you put in for it. Now, if you put in 2 values into range, it goes from the first value to minus 1 of the second value. It's kind of the same way the index works. So why this is useful is sometimes you just want to loop through certain numbers. You don't want to loop, you want to loop through certain years. You just want to build that range dynamically. You don't want to define it as a variable. You just want it for this loop. So here, if we want to loop through 0 through 99, we can do for I in range up to 100, but not including, print I. And it should print out, if you try this, 0 to 99. So we can try this all together. For I in range 100, print I. And so hopefully we get 0 to 99. And if we go all the way up, let's see. So for people who are familiar in R, like that, this is the same as like the sequence function. Escaping me if there's one in SAS or anything else, or in Excel, but this is just a way for you to build a quick list that you don't want anywhere else. You just want to loop through those numbers right now. So for and if are good, but the other traditional loop that a lot of people learn is while. And Python has that same thing. And you can imagine the syntax for it is also very simple. It's just while a condition is true, colon. So there's a while and there's a logical statement. So long as that logical statement, each time you iterate over, the test for that logical statement returns a true or a 1, it'll keep looping. And you can use break and continue in the way you traditionally do for other programming languages, and they should still work for R, for Python. You can break out of that while loop if it reaches that break. You can continue if it's still false. So here we have a loop that's saying we have a list, and so long as I is less than the length of that list, print out I. But each time we loop through it, add 3 to I. So essentially what we're saying is print out every third element in that list. Because we're adding 3 to each one, but we're also printing out that element each time. And the minute it's over the length of A, just stop so it doesn't throw back an error.
So what is A here?
So A is any list we've defined prior. We can define it as anything else we want. So let's try it together. So let's define a list together as something as A, and we can call it anything we want. Again, a list is just anything in square brackets, right? So let's just do 1, 2, 3, 4, 5. So if we look at A, it's 1, 2, 3, 4, 5. So while let's see, while I is less than hold on. Okay, so we need to define our variables before. So if we say I is equal to 0, right? Because if we don't define I before we test it, Python is looking at something that doesn't exist and it'll throw back an error. So I equals to 0. So while I is less than length of A, print that index, right? That slice of A. Now, let's say we don't want the third element, but we want every second one. So let's do I plus equals 2, which is essentially saying I equals I plus 2 each time we loop through it. And hopefully, that'll give us that, 1, 3, and 5. So it gets us the first one, it adds 2, so it gets us the third element, then it adds 2 and it gets us the fifth element. Okay. So, like we did with strings, lists also have methods on them, and they're very useful in the same way they are for strings. They're ways to manipulate the list in the same way we want to manipulate strings. But they're also, you can imagine, a little different. So the first one, and it's probably the one you will use the most often for lists, is you append something. You want to add something to the list. So you append. So you have a list you define, you do dot append whatever element you're trying to add to it. And it adds a single element to the end of that list. It just adds it to the end. So, and this is just a warning which I put in here, is that a very common mistake is that people, again, imagine this method spits out a new list with that additional element. It does not. It goes into that memory and it modifies the original list and adds a new element to it. So what if we don't want to put it at the end, then we want to put it somewhere in the middle. So we do the insert method, which is we insert something at the index we give it, shifting the elements afterwards one by one. So we insert at the index this element, and it pushes everything after that element, after that index, by one. That's a way of putting something into the middle of the list if the order of that list is very important to you. So, but sometimes we don't just want to add one element. Say we have multiple lists of things, and we just want to add them together, right? We want to make a new list that is the combination of the two. We saw before we can use the plus sign. The other way to do that is the method extend, which is equivalent to that, which is list.extend list2. So the plus sign spits out a new list that you can define somewhere else, add to a new variable. List.extend modifies the original list to add the elements of list2 to it. So the distinction here is if you're trying to define a new list, a new variable, you would do the plus. If you want to extend your existing list with some new series of elements, you would do the extend method. So what if we want the reverse, which is we want to know, we know a given element, we know what it is, but we want to know where it is in the list, right? So here, list.index searches for the elements in the list from the start to the end, and it pops back the index of the first time it finds it. Now, if it doesn't find it, it throws back a value error. It's saying it's not in there. So this is a way of testing it that'll error out. It'll stop the program if it's not in there, if you want the program to stop. Another way we showed before is you can use in, which doesn't stop the program. It just returns a true or false. It doesn't give you the actual index number. This does. Now, what if we want to remove an element? Say, like, we have a list of customers, and we know this one is no longer a customer of ours. We want to remove it from our list. We know their name. So we remove that element. That's the method. So list.remove element. And it removes the first instance of it, starting from the beginning of the list to the end. It removes the first instance of it from that list. So if it cannot find it, again, it will stop the program. It will error out, and it will say value error. So this is also very useful, which is the sort. So oftentimes, you have a list of elements, and you want to sort it by some way. List.sort sorts that list. It does not throw back a new list. So when you call this command, it doesn't do anything. It looks like nothing happened. What it did is it sorted that list in the memory in its place. This is a very older method, and it's generally preferred that you use sorted, which is a function we'll cover later, as a better way of sorting things. List.sort is just a very quick way of doing it. We can test that here in, oh God, what did I just do? Spoilers. Okay. Okay, let's try this. Let's make something that's out of order. A equals 5, 3, 7, 8, 1. Then we do a.sort, open close parentheses. Nothing happened. It doesn't look like anything happened. What it did is it took A and it sorted it. So actually in the memory. So what you defined as A, that order changed. Right, so we'll get to that. And that's why it's preferred to use sorted, which is a function and not a method. So, so if we just want to reverse the order of it, this is the method to do it. So list.reverse, and it's similar to sort. You don't pass anything to it, nothing happens. It's just that what A is actually changed. What the list is actually changed.
Default of sort is ascending.
Yes.
How could you change that?
Right. So the preferred way is to use a function called sorted, and we'll cover that at a later point. This is generally a quick hand if you just want ascending. Okay. So pop is a very interesting function method, and what it does is it takes, you give it an index, so the place in a list, it pops it out. So it's exactly how you would imagine popping something out. So it takes that element at that index, it returns that, but it also deletes it from the list that you were looking at before. So say I want to go through a list, but each time I find something at this index, right, I want to remove it from that list again because I've done something to it and save it to something else. So if we were to test that and say we have A, and we want to remove the 5. So what index is 5? Sorry? 2, right? Because we start at 0. So A2 gets us 5, right? And we want to pop it out. We want to get 5 back, but we don't want it in the list anymore. We're done with it. So we do A.pop the third element, right, which is 2, gets us 5. But if we look at A again, 5 is no longer there. So it's a way of going through it and making sure this thing isn't in there anymore after you're done with it. Now, the thing to be aware of is that as you're looping through a list, you should never try to remove or add something to it because it messes with the way the iteration happens by Python. So you should only do this if you're not looping through this specific list. So this is sort of the opposite of appending something. You're just popping it out and removing it from the list. So a common way, like I mentioned before, to build a list is to define it as empty first, and as you get more elements in, as you're defining more elements in, add it each time piecemeal. Right? You can imagine looping through some giant like string, but like every certain element you find, add it to the list, right? So here we define an empty list called list, and we do square brackets. Now if we were to append, now we start appending things that we want to add to it, A or B. So that's a very common way. You have to substantiate the variable before you start doing anything to it. So the minute you define the list in square brackets, it knows this variable is a list. Now all the methods apply to it now. So append applies to it, so you can start adding things to it. So we can slice that list again too. Why is it not updating? There we go. Okay. So like we did the strings, we can slice this list. And so if we were to print list 1 to -1, it'll go from the first element up to, but not including, the last element. If we do 0 to 2, if we were to replace it with something else, it would replace those elements with the single elements. So if we replace the first, if we set list 0 to 2 equal to Z, it's looking at A and B, that sublist, and saying, well, we're tossing that out, and we're adding one element into it. And so if we were to print list again, we would get Z, C, and D.
So how do we allocate or free up memory for lists?
So Python does that automatically in the background. You should never have to worry about that. So it's really limited by your computer specifications, and there are still ways to clean memory garbage in Python, but those things you should never do. If you're at that point, you're probably doing something wrong. Most of the time, if you define a list, that memory is allocated to you automatically by Python.
Can you delete that list though?
Yes, you can remove a variable, and that list will be gone from memory. But the thing to be aware of is Python automatically cleans the memory as it goes on. So if certain things will get wiped out if it no longer is used. So the same way that, say I've defined like range from 0 to 200, the minute I'm done that loop, that memory is gone. It cleans it because you don't need it anymore. So that's how it defines it in the logical blocks. So a lot of that is, like Python is meant to do all that in the background for you. You should never have to worry about it. Yes, question? No. So that's the thing that you should know is that we're saying 0 to 2, and when we slice that, it gets us a sublist. Yeah, not both elements. Yes. So the way to replace all elements is to loop through it and then set all of them into Z. Okay. So we get to the more preferred method of sorting the list, which is sorted. It's a function. It's not a method. It works on the list. What it does is it doesn't change the existing list. It spits back a new list, a new copy for you. And here, the default, if you don't pass anything to it, is sorts ascending. So you'll see here, if we define A as 5, 1, 4, 3, if we sorted it, it would be 1, 3, 4, 5. But A has not changed. It's still 5, 1, 4, 3. Now people are asking, how do we do the reverse? How do we do custom sorts on that list? And so the typical is, if we want to reverse, there's an option. So you just pass the option in sorted to be reverse equals true. By default, it is false. It is off. So you'll see on the third line, if we sort the string and we do reverse equals true, it'll sort it backwards from descending order. So you'll also note that Python is case sensitive, so the sort is also case sensitive. Now what if we want more complex sorts? What if we want to look at the length of each element? And that's where the option key comes in. So in sorted, we can pass a key. That's basically any function that returns one value, that acts on each element of that list and returns one value. So len is totally something that does that. So len on each element of that list returns one value. It returns the length of that element back to you. And so it'll sort by that returned element. So if we do if we sort strings, this list by the length, key equals length, right? It will sort it in ascending order, the length of each string. Right, and you can pass it any function that returns one value back. So here, you can also pass it the method, which is lower, right? So we want to lower case the string, right? So if we know each element in the list is a string, we can call string.lower, right? And this method will convert all those elements into lowercase and then sort on that. It returns one element, which is that original element for lowercase. So here you saw before that it's case sensitive, right? It'll sort first with the capitals, then with the lowercase. Here, if we pass it string.lower, it sorts it after it's converted everything into lowercase. So you can imagine the same thing would work if you pass string.upper, because it changes everything to uppercase.
So does the string.lower, does that work on the entire list, or does it work on each element of the list one at a time?
It works on each element of the list. So it has to be a function that works on each element of that list. So here we have an example. So we can define a custom function that returns one element back that works on each element of that list. So here we decide to define a function called myFunction. It takes in S, and it returns the last element of S. So if we were to put that in our key, it would sort by the last element of each element in that list, right? So if we look at this, you can see it would get back WAZBXCYD, because it looks at the last element of each, last character of each element in that list. Now that's overly cumbersome if you don't want to define a function. Python has a shorthand called lambda, which is a way of defining a very short function that returns one element. So the conditions of that happen to match with key. So typically you'll use lambda and key. So you'll see the fourth line, print sorted strings key lambda x. That is essentially the same thing as defining the function and then passing the function. You will get the same thing again. So the way lambda works is you say lambda x colon or lambda whatever colon and then something on that variable you defined. So here I'm saying lambda x, given x, give me the last element of x. And that is exactly the same as what I did here with s in my function. So we can test this out together. Let's say a or s equals hello world. Right? Okay. And we want to sort by, I don't know, the last element again. This is probably not a good example because anything else sorts back the way it works. So we do sorted of s, and we key equals lambda x. So we're saying for the variable x, for each element x, give me the last one. And it sorts it by the last element, which D comes before O. So we can change that, and we do 2 second last elements, and you get hello world again. So it compares L to L. Is that clear? So this is a very easy way for you to do custom sorts on a list. So if you can conceive of, say, let's try do like A equals 1, 5, 2, 6. No, forgot the equals. And I can't type. Okay. And we want to sort it, and we want the key to be, I don't know, sort by square of x, which would just be the same as extending, but it actually sorted on the square of it. So anything will work. So if you do -6, so long as it returns one variable, it'll sort by that. Or returns one value, I'm sorry. Okay. So the next built-in type that's very common and used for Python is a tuple. And a tuple, we said before, you'll notice there's a consistency in Python. So anything that's a string is contained in quotation marks. Anything in a list is contained in square brackets. Anything in a tuple is contained in parentheses. So you typically think of tuples as coordinates in some space. People who are familiar in math, like x, y coordinates, so on, latitude, longitude. Now the thing about tuples, and they're similar to lists, and they're similar to strings in that they're immutable. So the elements in the tuple don't change. You cannot change the size of the tuple. You cannot make the tuple larger once you've defined it. You cannot change that place in memory. You can make a new one, but you cannot change that. So what's useful about a tuple if you can't do anything to it? Well, it typically acts as a structure. It's sort of defined in a way, so it's fixed in a way, so a lot of functions know these certain elements of it. So let's say we define a tuple as 1, 2, and high. The length of the tuple is 3. If we want the last element of the tuple, it's high. If we want to change the last element of the tuple, we cannot change it. But if we redefine it in memory, if we change what tuple is actually defined, we can change it. So we can't change the individual elements of it, we can change the whole tuple again. Does that make sense? So unlike a list where you can go in and change each element and set it to something new, you cannot do that with a tuple. Once you've defined it, you cannot go back and change it. You can rewrite it with something new completely. So oftentimes this is something that a lot of people have trouble with when they're first starting out, is that they want a tuple that's size 1, just one element of the tuple. And to do that, Python actually needs an additional comma. Because otherwise it looks like it thinks you're doing a logical statement or you're doing some math operation. So you need that comma in the tuple to tell it that this is an actual tuple. So the tuple we defined here, high, is just a comma. We add the comma to tell Python that this is a tuple. That's one element. So this is a shorthand that's easy. So say we know how long a tuple is. We say we have GPS coordinates. We have lat and long. And we would just want the lat and the long. We want to assign it, each element in that tuple, a variable name, right? So if we were to put lat and long in a tuple and the actual coordinates in the other tuple and set them equal to each other, we'll assign lat as the variable name for that actual coordinate, and long as the actual variable name for that coordinate. So we can test that out here. Let's say chord equals, I don't know, like 19.2 65.45. That looks like a GPS coordinate. Negative 65.43. People at NOAA can correct me or send me angry emails afterwards. So say we want lat and long, right? Let's do lat long equals chord. And now what's happened is that lat has been defined. We've assigned multiple variables in one single line. And same for long. So just an easy shorthand for you if you have multiple, you have a long tuple and you just want to assign each one a certain variable name. Yes. Yes, you can. Yeah, so Python is dynamic in that way, so each element of that list is autonomous. Each element in that tuple is autonomous, so they don't have to have the same type. So the important thing to know is to do this shorthand, you have to know the length of the tuple you're assigning variables to. So if they don't match, you'll get an error. So if we try that again, and we say just let, it'll say you don't have enough variable names to assign the variable values. It'll stop the program. Python, in general, defaults to stopping the program if there's an error. So here we get to something that's very useful, and it's list comprehension, which is something I think as you master will be more and more useful. It's shorthand for doing a loop, a for loop of every iteration in the list. So instead of writing for something in a list, do this. This is shorthand for that. So say we have numbers, which we define as 1, 2, 3, and 4, and we want to square each element of them. The way to do that is to put it in square brackets, and the syntax is square brackets, the expression you want to do for the variable you want to do in the list you want to do. So here we see we want n times n, which is essentially square of n, for every n in the list numbers. And what you will get back is the square of each element in that list as a new list, not replacing it in the memory. And this is very useful in that this is very shorthand, and this is a way for you to do operations on a list without writing out the full loop. And the thing is that Python actually performs better in list comprehension than an actual for loop. So this is something you should try to master as you get better at it. This will be more obvious. So like in the for loop, we can also add a conditional statement to it and an if statement. So say, what if we want to subset a list? We want to go through the list of every element and we want to test it to see if it fulfills the value, right? So say we have a list called nums, which is 2, 8, 1, and 6. But we want everything that's less than 2. So in list comprehension, the syntax for that is the element you want to return for the variable in the list that you want if that element fulfills the statement. So here we want to return n for every n numbers only if numbers is less than or equal to 2. So the if statement comes at the end. And this will get you actually a subset of that list, which is 2 and 1. So it's a quick and easy way for you to subset list by some value that you want to know, some test. And so that if statement operates exactly like the if statement before. Any logical test that returns a true or a false or a 0 or 1 will work. So in the second one, we do both. We do some operation on every element in the list, and then return it only if it fulfills some condition. So say we have fruits, apple, cherry, banana, and lemon. We want to capitalize that string only if there's an A in that string, right? So we do capitalize that string so capital uppercase S for S in fruits only if A is in S. And that'll get you apple and banana, uppercase. Okay, and I was right. I think we have an exercise, which is, so given this, and people who may have forgotten already, a range gives you a sequence of numbers up to but not including that last number. So it goes up to, so range of 100 is from 0 to 99. Can we square every odd number in that list using list comprehension? So this combines an operation on that element and a condition. Yeah. So let's say I'll give about maybe like 10 minutes to try this, and maybe another 10 minutes to take a break, a bathroom break, a water break for everybody. So we'll reconvene at 3:28, 3:30. Okay. And again, we'll be here for if you have questions or help, or you need help. Sorry. You know all the mathematical functions. Hopefully everybody at least got to this point. Okay, moving on. So we get to one of the last built-in types that it's probably, for people who aren't familiar with sort of like web development or like JSON or something, this might seem a little foreign to you. And it's called a dictionary in Python, and short for, it's often shortened as dict or DICT. And the idea behind a dictionary is the ability to efficiently have a key value pair. So what does that mean? So it means that you have a specific key or label to a specific value in a dictionary. And so you'll see here, those are represented with curly brackets. So like in Python, everything has a consistent type. So a string is always in quotation marks, a list is always in square brackets, a tuple is always in parentheses, a dictionary is always in curly brackets. So the way to define a dictionary, if you just want to define it flat out, is to say the dictionary is equal to curly brackets, the key, colon, the value, comma, for each key and value pair you want. So why is this useful when you have lists that you can look up, when you have lists that you can iterate? And the reason is this is much faster. So if you have a specific value that you can attach something to, and you always want to look it up, you don't want to iterate through a list to do this. This is much faster. It's about efficiency to have a key and value pair. And so the way to look up a specific value, if you know the key, is to put that key into square brackets. The way we would put an index into square brackets for a list or a string. So you see here, foo is the key. So let's just work this out for everybody. Let's say we have a dictionary called B, so squiggly brackets. Let's say foo bar. Right, so what does that say? That's saying that the key foo is attached to the value bar. Right, so we've defined B as that. So if we were to look up the key to something, say we know the key is foo, B, it'll return the value bar. And the reason why they do this is because it's more efficient than iterating through a list to look for something to do anything conditional on a list. So here we have a couple examples. Oftentimes, like a list, a dictionary can be built piecemeal upwards. So we define an empty dictionary that's just the curly brackets, and we add key value pairs to it. So the second line, A is the key, and we're saying the value is alpha. Third line, G is the key, gamma is the value, and so on and so on. So we can keep adding key value pairs to it as we go on to build out a dictionary. So in this way, they're like lists that you can build out. So if you were to do all those things before, and we printed it out, this is the format you would see it in. It would list every key value pair in sequence. Now it's important to note that in dictionaries, the order in which these key value pairs appear, like that they're sorted in, is not important. Because you're searching not based on an index, you're searching based on a key. So they list them when you print it out, just in alphabetical order. Because the order is not important. So you cannot sort a dictionary because it has an implicit key attached to each value. So given that original dictionary we defined, right, if we were to look up a specific key, it would return alpha. We can assign a new value to that key and say, let's make it equal to 6. Then it puts a new value to that key. We can test if a key is in a dictionary the same way we can test anything is in a list. Just say, when we say, is something in a dictionary, we're really saying, is this in the keys for the dictionary, not the values. So if we were to ask Python to print out a key that doesn't exist in the dictionary, it'll throw back an error, it'll stop, and it'll say key error because it doesn't exist. We can put a conditional on it and say, if it's in the dictionary, then print it out. That'll avoid the key error. We can also ask it to get the key, and that'll avoid it. It'll say none. So we can test these out. So let's say A equals alpha. G equals gamma. So you see, it just rearranges the keys because the order doesn't matter to it. Because you have keys implicit to it, it just sorts it by some way. So if we were to ask it for the key O, it'll give us omega. Now, what if we want to reassign that as OMG? We can reassign a new value to it. Now, what if we want something that doesn't exist? Z, key error. We can test if something is in a dictionary, and it tests only the keys, the list of keys. So is Z in A? No. Is G in A? True. It only tests the key values. So if we were to loop through it then, obviously, it only loops through the keys. So if we were to say for key in a dictionary, prints key, it would print only the key values. It would not print the actual values themselves, not the. So let's try this ourselves and say we have A, and we say for key in A, let's call it anything else. We can say for X in A, print X. And it prints only the keys for it. So if we wanted to actually get the values for it, typically you do A, X, right? Because you're calling from that dictionary that key, and it's telling it to return the value. And again, I just want to reiterate this again and again. The order in the dictionary does not matter. They'll just appear in any order they want. Sometimes it seems like alphabetical, other times it doesn't. There's just no way to tell. So the way to explicitly request either the list of keys or the list of values is the methods .keys or .values. And obviously .keys gives you the keys, .values gives you the values. And so this is a way, if you just want the list of values, and for some reason you want to toss out the keys that are associated with it, you can do that. If you want to do the vice versa, you can do that too. And so what if you just want the tuple of them? You want the pair. You want the key and the value every single time you iterate. You want the list of that. So then you do the method .items. And it returns a tuple, the first element being the key, the second element being the value. So this is often, if you just want to examine the dictionary, this is the easiest way to do that. Because it's equivalent, the first line, print dictionary.items, is equivalent to the second line, which is for every key in a sorted dictionary keys, print the key, then print the dictionary key, right? The value for the dictionary of that key. So those two lines are equivalent. So we saw before, if we have a string and we want to put a value in, say that's a number or a string, we do print percentage, D for integer, F for floating point, S for string. Now, since we have a dictionary that has assigned keys to it, we can also do replacement based on the keys given a dictionary into a string. So say I have in a dictionary defined a key called word, which is Garfield, and a count, which is 42. Now, I want to put the count in, and I want to put the word in. So the way to do that is to say percentage, parentheses, the key, close parentheses, and then what type it is, either an integer for D or a string for S. So this is useful if you have components of something that you want to build up together, like a mailing address or something. You have components that are assigned a certain key, right? This is the street address number, this is the mailing address, this is the street name, this is the street prefix, suffix. You can build that out piece by piece. And now we get to the thing somebody asked earlier, how do we delete variables from memory? Say we assign something and we don't want it anymore. We know explicitly we're never going to use it anymore. And so instead of Python trying to clean it for us, we can explicitly delete it. And the way to do that is del, D-E-L, just delete it. So any variable you assign, if you do del, that variable, it deletes it. That variable is no longer assigned, and it is freed. You can also do this for specific list elements, specific slices of elements that you don't want anymore. You just want to wipe out. So it doesn't have to be on the whole object. So with all that in mind, of all these methods and all these functions and all this syntax, what we're really trying to get at is, I think a lot of us the idea is we want to be able to put in data into Python. We're not going to input this by hand. So the way Python works is that it has a function called open, which opens a file in your desktop or in whatever drive you have. And you pass it a parameter, either saying you're going to write to it, you're going to read it, and by what format. So the open function opens that file, right? And you pass it the file name, and then how you're going to open it, either R for reading or W for writing. So if we're opening a file to load in, we're probably going to read it. We're not going to write to it, right? We don't want to overwrite anything. So we do, the typical traditional is f equals open, the path to the file, and then the how you're going to open it. Now the important thing to remember when you're opening files is that Python opens that file and does not close it. You have to, if you assign it to a variable in here saying f equals that you open the file, it has not closed it for the duration of your program. As you run it, it remains open. So you have to explicitly pass saying f.close to close that file once you're done writing to it. So we can use R to read, we can use W for writing, and we can use A for append if we want to add to a file. So there's a special mode that you can pass, which is U, capital U, which stands for universal. And what happens here is that different OSs will append a special character to the end of lines in programs. So like Windows passes like, I think it's technically like tab new line or something, or tab return carriage. And it's different for Linux, which is tab new line, and different for Macs. So in the universal option, Python will automatically account for all those differences and just replace all of them with new line. And why that is useful is because then you do not get special characters at the end of your strings. You don't get mix-ups in programs. You don't get how the whitespace, like because Python is so dependent on the whitespace and the formatting, this doesn't mess it up. Especially because like if you're pulling in strings or logs and you don't want those special characters at the end, you just want a new line each time you print it.
Will the file close if I end my Python session?
It will. But we're going to address a better way of opening files shortly. So here, the very traditional way that people think of how to open files is you assign a variable and you assign it a file that you open. Then we can iterate through that file. And the way it does it is Python reads that file literally from the top down. So as you iterate through it, so for a line in F, it's literally reading every line in F. So every line in through that text, it reads it line by line. And you can print that line, and then after you're done, you have to close it explicitly. Now, like people ask, like closing it is in a big giant program that you're writing, you don't want to do that constantly, or you might forget it, and that eats up memory. So the way a lot of people do it now is you do with, and 2% of this works, which is you say with opening a file as F, do all these things. And that only defines F temporarily. So it closes the file automatically when you're done. So you never have to explicitly say f.close.
Are there any predefined data parsing functions for files like CSVs or TSVs?
Those are in additional packages. So are there any ways to parse CSVs or like additional files? They're in additional packages that you can load into Python, and we'll show you how to do that later. So I think CSV, which is a very common format everybody uses, that's the default package that comes with Python. And the documentation for that is very well No, you can look it up. I'll show you how to import a package. So, okay, that's a good question. Segues into how do we import packages into Python? So now that we know how to open it, typically we want to be able to either write to it in a specific format or read it in the site, like parse it in a specific format. CSVs come with Python, the package CSV. So for everybody who in the terminal, if we write import CSV, it should work. So that comes default, and you can look at the documentation on how to parse it. And what it does is essentially each line in the CSV, you pass, as you open it in F, you pass that line to the CSV, and it'll parse it. It'll read it. And you can assign it variables. But I want to get to something I think is more useful. So I don't know how many people have used JSONs before, where it's really a web format, and it's meant to be human readable. So for people who use R, there's you can save the session, right? And you can get back to it. For Stash, you're writing automatically to tables, and that output is automatically saved. For Python, that's not true. So you don't really save the session. You can save the program as you're writing it, right, in a separate file. But like the dictionary or the list you built, that doesn't get saved. Either you have to write it to a file explicitly in your code, right, or it doesn't get work. So there is a workaround people have developed, which is called Pickle. Due to security concerns for DOC, like Pickle there's a flaw in Pickle, which is you never want to open anybody else's Pickle file. So I will skip over that today, and we'll go over to something I think is much more useful, which is a JSON, which is human readable. So it's a text that you can open and you can read and parse yourself, so there's no malicious code in it. And so you can transfer that back and forth to people, and you can write it. So I asked before the class started that people install UJSON. If you have, you can import it, and I would recommend importing it as JSON. So if you have UJSON and you write the first line, import UJSON as JSON, what that does is it imports the UJSON package, and it calls it JSON. It gives it the name JSON. Now, if you don't have UJSON, the package JSON comes with Python too, so you can just import that. So we can try that. I have UJSON installed, so that should work. Or if I type it correctly, it should work. And so the reason I'm covering this is a good way for you to save your files, because JSONs have a natural translation to dictionaries and to lists. So the way data is structured in Python has a natural translation to JSONs. And so the way you read and write and load to it is very easy back and forth. So for JSONs who aren't familiar, it's an open standard. So the specification for it is available for everybody. It's supposed to be human readable, so you can parse it. It's not in binary or anything. And data objects, you'll notice, have an attribute value pair, which sounds very familiar, right? So it's essentially like a key value pair. And so, in fact, when we write to a JSON, a dictionary, it writes it as an attribute value. And it looks very similar to a Python dictionary. So JSON's included with Python. So for those people who don't have UJSON, Ultra JSON, you can use JSON instead. You can just import JSON. For those who have UJSON, I would recommend using that. And the reason why is because the default JSON package is very slow. Like if you're writing a large dictionary or a large list to it, it takes a long time. Or vice versa, if you're trying to load it back into memory, it takes a very long time to read it in. So Ultra JSON is just a much faster way to do that. So here's an example of a JSON file. And you'll look, it's very similar, right? Curly brackets for dictionaries, right? There's a key, colon, value pair. There's square brackets for lists, and so on and so on. So it's the values map, the format maps very nicely to Python. And so if we have loaded JSON in, and we opened that file, and we read it, the command to assign it to a variable is just this. You don't have to read every single line. You don't have to parse it. That whole file gets dumped into this variable. And it reads it automatically. So here you'll see this was a dictionary. When we load it in, the loaded file will be a dictionary automatically. If it was a list, it will be a list automatically. So it's a good way of backing up and loading your session if you want to do this. So if we were to write it, we would do pass W instead of R. And we would dump the file instead of load the file. And so the advantage to this is that once you've written it, you can pass this file to somebody else. And the idea is it's human readable. So the key values are there. They're very line by line. It's very parsable. And if you Google JSON on the internet, it's a very widely used format. It's very well known. It's particularly well known for a lot of APIs, a lot of web formats for websites and everything.
You're using with open.
Mm-hmm.
Does that mean that all of your code that uses that data that you opened has to be indented after that?
No. So if you're loading the file in and you do with open, the minute you assign that value to a variable, you're done. None of your code has to be in that with open anymore. It doesn't have to be indented anymore because you've assigned that value to a variable now. You can use that. The loaded file is a variable that has been defined now. So we can try this. Let's so we've imported JSON. So let's say A equals some dictionary, 1, B, 2, and now with open test.text or test.json, comma, we want to write to it as f, json.dump af. Huh. Okay. So my mistake. You do not use the universal tag when you're writing, so only when you're reading. There we go. So that file here somewhere. Open a new terminal. Yep. So more.test.json. Yeah. And you'll see it wrote it out to test.json. That's just a text file with the actual dictionary defined in the same format. So if we want to load that into a variable, we do with open test.json, read universal as f, b equals, you notice we defined a already, b equals json.load f. And hopefully, You get that. So one downside is that when you dump to a JSON file, it converts it, when you load it back in, it converts it to Unicode. And for most purposes, that doesn't mean any difference to you. It's just a string. So B is our loaded in file once we've dumped it, and A was our original. So the only difference is that the strings that we had to find originally before are now Unicode. But for most purposes, you should treat that as exactly the same. And you'll notice we didn't have to close the file because we used the with open, and so that only opens that file temporarily until we're done with the logic block. Okay, moving on. And so this is sort of the last thing I wanted to cover for everybody today, which is NumPy. And so NumPy stands for, what is it, numerical pi? Numeric pi or some Python. And it's part of a suite of packages known as SciPy. And it's usually, it adds additional functions to base Python for scientific research. And so for a lot of people here, the use for NumPy is probably the first and the last bullet point. So I'll read through them. And so NumPy adds on to Python a powerful array object. So you can do arrays, traditional arrays, say in like C or something, in Python. It has broadcasting functions. It integrates C and C++ and Fortran code. What that means is it's much faster than default Python code, because C operates on a faster, and Fortran operates closer to the metal, so it's faster. But the thing that's probably most useful, it has a lot of linear algebra functions. If you have this giant matrix and you want to transpose it, you probably have that. It has Fourier transforms, and it has a lot of statistical and random number using functions. So if you want to generate like uniform variables, if you want to get the mean, the standard deviation, this is the way to do it. And so for people who have installed SciPy and NumPy, the way to import it is to just say import NumPy. And typically people will use shorthand because NumPy is a long, it's just too many letters to type out again and again. You do NP. So import NumPy as NP, call it NP. Right? And so it has a set of functions. It has a wide list of functions that you can call on from NumPy, and they're very useful in very like scientific case, like a lot of linear algebra. If you're trying to build a giant array of functions of numbers, and you're trying to like transpose it, do linear algebra functions, the cross product of it, that's very useful. But also, for a lot of people who are like used to Excel or something, they just want like descriptive statistics. This is also very useful because it has all those things in there. So say we want just some list and we want the mean of it, or the standard deviation, or the median, or all those things. Instead of building out our functions ourselves, NumPy has that function in there. So let's just try this on our own. So let's say A equals range from, let's give it like 1,000. And we want NP dot mean, because that's a function from NumPy. So that's always the syntax. The name of the package dot the function of A, and it does it. If we want the standard deviation, does that. The variance, yep, median, and so on and so on and so on. So it has a lot of those values, and you can look up more of them. The documentation is very well sorted. It's a very well used package, and so this sort of gets you to the point we were typically used to in say Excel or SAS or in R. You're getting your proc freaks, you're getting your descriptive statistic summaries in R, sort of all those things in Excel that you're like summing up, you're doing the mean, you're doing the average of. This gets you that same functionality, but much more powerful. You can do it much faster, you can do it a much larger data sets, you can save, you can write to it. Wrong one. And with that, I think we are done. So I'm only 5 minutes over. So let me go back to the top again. My name again is Ying. TA has been a pre-override. We're part of the Commerce Data Service that's offering these courses for everybody in DOC. Let me type in, is it Data Academy at doc.gov? Oh, okay. Yep. So at doc.gov. So you've probably already received emails from this address already. But if you have any questions, feel free to send it to there, and we'll get back to you as soon as we can. I'll leave it open to any questions or any things you wanted to add last minute, but otherwise we're done. Thank you. Yes, we'll post them. I think we've been posting them to GitHub. Is that what it is? And then we'll send the link from GitHub to everybody.